Now we'll talk about writing into cache. Okay, so far we have not seriously taken these writes in cache, but they are not so easy. They are little bit complicated and they are different from reads. Okay, we will see the differences between reading the cache and writing the cache. Okay, now example, let's say you have a processor and this is the scenario, either because of instruction fetching, otherwise operand access which is in main memory, we generally wants to go to main memory, correct? Two reasons. So whatever may be the reason, when you wants to go to main memory, for that we have already main memory address. Okay, you have a main memory address and you want to go to that main memory, but data is sometimes in the cache. That's why always your processors will be designed such a way that this main memory address will be taken and the appropriate block will be identified. That means which main memory, we know the process, right? Based on direct map technique, otherwise associative, based on that, using this main memory, we finally come to the cache, right? That is nothing but looking into the cache. Assume that let's say you're reading the data, okay, which is specified by this main memory address. Then for that, this processor will have a hardware such a way that automatically will come to the right block. Okay, let's say this is the block currently relates this main memory address. On that, let's say we have to read this particular word. Okay, there will be word offset. Using that, we will read it. That's it. Very easy, right? But you don't really require to update anything in main memory. We never touch main memory if the cache gets hit, right? But if you miss in the cache, then what are you going to do? When there is a miss when you are reading, then immediately we will go to the main memory and we access the corresponding word, right? Before that, before accessing it, generally the scenario will be, however, all these main memory block will be transferred here, which is the right one. Okay, example, this is a block which you are referring, then that block will be copied here, then after that the appropriate word will be taken. Understand? So and one more thing, so there are a lot of different ways people can do. That means depends on the architecture. So many different ways we can do the things. Understand? Maybe I can first read the memory word, desired thing, then later I can move the block. Anything is possible, right? Don't worry about them. That's why I don't want to go into that details first. So what I would like to say is, finally what happens is, all your main memory block which you are referring will be transferred to the cache. You remember this, forget enough. Then after that we read again this cache block, and especially we will read our desired word, right? This is about reading. So reading is done. When you get hit, what happens? When you get miss, what happens? We have seen. Now we will see writes explicitly. So writing is a big story. First of all, we start with write through procedure. What is write through? I will tell you. First of all, whenever you are writing, the example instruction is store instruction. Because of store instruction, we write something into the main memory, right? So this is a main memory address. And first, using this main memory address, we will come to the cache. We know how to convert this main memory to appropriate cache block, and we will come to cache block and we will check, right? And we'll check the tag fields, everything, right? So after that, let's say finally you realize that there is a hit. Whenever there is a cache hit, that means your data is available in the cache. Then you write appropriate word. I will show clearly. So this is your cache. Let's say I'm showing in a bigger way so that easily we can understand. This is the word, let's say you want to write. Okay, this is the word which you want to update, right? That is what write, correct? So this is the position. For that, because it's hit, you get it and you will come to here and will update it. Okay, so you updated it finally. That is about hitting, right? But the problem is, generally when you just update in your cache but not in main memory, we have the corresponding word here also, right? Example, this is word number 1. Then in some main memory block we have the data, right? Because we know that we follow inclusion property. That means whatever you keep in the cache, that must be present in main memory, right? Such a way we plan. So that's why, so your main memory also contains the data, but you are modifying the word number 1, right? Let me put star. This is your word number 1 which you are referring, but that is not modified here because you are accessing in the cache. That will occur. So what, sir? I never touch main memory. Always I take the data from secondary memory. Sorry, cache. No. Sometimes what happens? So there is a second memory called secondary memory, and there is a concept called direct memory access. So through direct memory access, sometimes what can happen is this data might be read by this secondary memory. That means we transfer this block here, hence W1 also might be transferred, then disk contains inconsistent data. Remember one thing, so consistency is very important. Whenever you are repeating the data, everywhere we should show the same data, correct? So that's why. So what to do then? So for that is the issue. I'm not saying that that's why immediately I should write. Okay. One alternative is, so whatever I'm going to talk about is write through procedure. Finally, you understood the problem. Whenever we write in the cache, okay, whenever we update, if it is present in that word is present in cache, we update that word. But you get inconsistency. I'm not saying that that's why we have to immediately write it, but I'm just explaining you that this is a possibility. Then the write through procedure is a procedure. What that write through procedure will do is it will update in the cache the appropriate word, and the same word will be updated here also. Understand? That is called write through procedure. Let me repeat. Whenever you are writing one word, that means whenever you want to modify a word which is specified by your main memory address, then go to the cache and search for this word. Let's say you got it. That is called cache hit. When the cache hits, then you get the word and go to that word and modify it. This is the word, let's say. Then immediately you go to the main memory, because we have a main memory address, right? For us, you know, going to main memory is quite obvious, easy, right? So, but it takes lot of time. That's a problem. Then go to main memory and go to the appropriate word. We have address of that. Simply go there and update it. That is write through procedure, very easy. But you see the complexity. So for every write, you have to visit main memory. What is our primary goal of cache memory systems? To reduce the access time, right? So it takes 100, generally the typical values will be like this. If cache takes 1 nanosecond, main memory takes 100 times, 100 nanosecond. Then you are wasting 100 nanosecond for writings, correct? So every write takes lot of time. Then you don't get benefit of cache, right? Then why to maintain another copy, right? Directly you maintain main memory rather than cache, then we will be happy, correct? So that's why. So generally write through procedure is not used. We have an alternative procedure, that is write back. Okay, before discussing write back, we will see an optimization in write through. So with write through, with a concept called write buffer is better than simple write through procedure. So we understood the problem with write through, correct? But you get a consistency, right? If you follow write through procedure, then data will be at a time available in the cache and main memory. Now if you use write buffer, I will explain what is write buffer. If you use it, then definitely you are going to do better than this simple plain write through procedure. Okay, we will see that write buffer procedure. Okay, what is write buffer is, this is just simply buffer, like I can say just set of registers. Okay, so it stores data. So this buffer is going to hold some words, whatever you give, okay, along with the memory addresses. So that is enough to understand what this write buffer contains. Write buffer can hold some of the words which are given by processor. That means processor is, you know, referring a word, right? Processor wants to modify some word, right? You have data. That data to be modified, that word, I say that is a word. Okay, example, let's say you are modifying here this word, right? Then the buffer will hold that word. Understand? So that is called write buffer. Then how we use this write buffer, I will explain. Okay. So now in write through procedure, what are we going to do? You have main memory address, right? And data. This is your main memory address, and you have data to write in the memory, right? So because of this main memory address, we realize that is this word's address. Then I will come to cache block, appropriate cache block, using the strategies already, you know. From now onwards I don't bother about it. Somehow I will come to the right word and I modify it. I write here. Okay. So new data I have already. Did you remember store instruction? Whenever we execute store instruction, then store instruction has data and memory address, correct? So we'll come to this memory address and we write the data. So finally that corresponding word is modified, right? Example, see the main memory. In the main memory you have a memory address 100 and already it is containing 20. Then store instruction can update it to 30, right? Correct? That is what happens here also. So there is a word here called 20 that is modified to 30 because of the store instruction, right? Then now see, let me show like this. This is the word called integer something 20. In main memory also we have that word, right? That is 20. Now because of store instruction, since let's say assume that a cache hit occurs, then 20 we will be updating it to 30. Then what we do is in the write buffer we will remember the address. Okay, so don't worry about details, it depends on the implementation. Assume that let's say we have memory address, at the same time the data, okay, we hold in a buffer called write buffer. Okay, and we don't update in the main memory, we simply update in the cache. Okay, 20 will make as 30, but we don't update in the main memory, but we only update in the write buffer. But write buffer is very near to your processor. It is not like main memory, which is after all like a CPU register. It takes very less time to access. That means parallelly I can access cache and this write buffer, and I write 30 here. At the same time I can hold it in the write buffer, right? So that there is no extra effort. Understand? Sir, why are you doing that? I will tell you. Then after that your processor will continue doing the next instruction. Okay, now it means what? Assume that let's say this data is updated, that means store instruction is completely executed. Only thing is we did not update in the main memory, right? So instead of that we write in the write buffer, then your processor will continue with the next instruction in the pipeline. Okay, now so what happens is there will be extra hardware. What that hardware will do is always that hardware will take the data from write buffer and address, and later whenever it gets time it will update that into main memory, not immediately. Understand? So that parallelly things can work. Understand? Now we'll see one example clearly. One hypothetical situation is you have a store instruction and lot of add instructions, add, subtract, multiplication and everything. So the beauty of this set of instructions is only the store requires memory access, correct? All these instructions doesn't require memory access. Then what is going to happen is, let's say you are executing, assume that again pipelining. In the first clock cycle you are executing cycle store instruction. In the second cycle let's say add instruction. In the third cycle, so in between, before that there are a lot of instructions. We know that in pipeline for every cycle we can execute a new instruction, right? So third cycle, fourth cycle, in that way. Now you see we are at now store instruction last stage. What is last stage? Updating the data in the main memory. For that we use cache, correct? So within one cycle we will come to the cache and we write that 30, and in the same cycle we write in the buffer also, right? 30, and we go. Then we execute add instruction, everything, we continue. Since all these instructions never require memory, then your memory is free, correct? Now your main memory I can say free. Now in these cycles, when your processor is executing addition, subtraction, multiplication, so no one requires this main memory, then happily if you design a small circuit which can independently write the data in the appropriate memory locations, so that we can save the time. That is about write buffer, right? So write buffer plus write through combination will can do lot of wonders, right? So this is about write through procedure. Now we will see an alternative. If there is no write buffer, then it will be very difficult. But sometimes what happens, you see, sir, what if this instruction is load? And what if you have another store? Maybe otherwise there is an instruction called add which does not require memory, but add wants to use data. Let's say add wants to use data, and that data, let's say, is coming from this one, from main memory. That means before you update it into the main memory, what some of the instructions wants it, maybe not directly add instruction, let's say load instruction. Load instruction wants to load the data from main memory, but unfortunately that load instruction wants to take the data from here. Then inconsistency will arise, right? Then sir, how you do things? Then remember one thing. So there will be, that's why we have to design a complicated hardware. That's why I just teach you the idea. I don't show the circuit. Okay, don't worry about the circuit. So what happens is there will be an extra circuit. What it will do is whenever there is a new instruction getting executed, that instruction's memory access, that means that instruction has a memory access, then only we have a problem, correct? If someone touch, this is 20 now, if someone wants to access main memory, and especially this one, I have a problem because I have not updated it, right? Then what I will do, before that itself I will update. But however, data is available here, right? I mean, if they go to cache, no problem, correct? If they come to cache, then I give my data. Even write buffer says, my dear other instructions, anybody wants to take the data from here main memory, first of all come to cache. We have data in cache, correct? If you don't get it, then before going here we ensure that we update here. That's why it's always possible, it's not a big deal. So these details are I can say not very important, but you understand them finally how the things works in the real processors. But what is important I will tell you for gate. Okay, because in gate we have lot of subjects, every point we cannot remember. Don't try to remember every point, but just go through them. You remember whatever you can, that's enough. Now important points about write through procedure is finally, if you have only write through procedure without write buffer, then we write the data into cache. Okay, if there is a cache hit, then immediately we will write in the main memory. If it is write through plus write buffer combination, then what we do is we write only in the cache, and temporarily we keep the data in the write buffer, and after that your processor will continue with the next instructions, and in the next cycles, if no one requires memory, then this write buffer will write the data into main memory eventually. By that time, before that itself, if you want the data, however it's already there in the cache, there will not be any problem. We will give that even from write buffer we can give. Understand? So that's why effectively write buffer is going to save our lot of time. Remember it. Now there is so far we have assumed that there is a write hit, right? What if there is a miss? Now we will discuss about write through procedure. Write through is not completed. Okay. So we have write through procedure, but there is a miss. What are we going to do? We'll see. This is your cache. This is your main memory. Okay, this is a particular. So now since it's a miss, so data is not available. So this is the word which you are referring. Okay. So this is your corresponding block. In this block, we are referring this word now. But there is a miss. We didn't get. What to do then? Generally, we have to bring this entire block into the cache, correct? So in write through procedure also same thing we do. What we do is, one simple solution is write all this data here first. Entire block will be moved because cache miss, right? Then all this block will be moved here. Then after that, the appropriate word will be updated. Okay. But sir, what about in main memory? In main memory also we do it. Then we update here also. Understand? Otherwise, first go to the main memory and update there wherever you want, because you did not get the data in cache. Then after that, this entire block will be transferred here. That is about miss. Understand? Now here also we can use write buffer. Okay, how write buffer helps here? Example, you have a write buffer. What you do is, you did not get in the cache, right? Then now this is the time to first of all move the cache block, right? So simply move right. Okay, move the data. Now we have to write it, right? Then write here. After that, tell to the write buffer, my dear buffer, I am going to give you one data and memory address. Whenever you get time, whenever this memory is free, whenever no processor is using, then go there and update. That is about miss. Understand? So let me summarize finally about miss. So whenever there is a miss, there are two strategies. One strategy is without write buffer. When there is no write buffer, simply take the data, first of all update in the main memory and transfer all the data to cache. Now cache also contains the data, write data, right? That's it. So that is about miss. Now second thing, what you do is first transfer the data from main memory. Okay, transfer the data from main memory, then update in the cache, the right in the right place, update it. Then same data you write in buffer, but don't update in the main memory. Why? This buffer is going to update that later in the other clock cycles. Understand? So this is about write through procedure. Understand? Now we'll see write back procedure. Before going to write back procedure, first summarize the write through procedure. In write through procedure, case number 1. First of all, I don't assume that I have write buffer. Without write buffer, write through, simple plain write through, and cache hit occurs. That means you are searching for a word and it is available in the cache and you are reading. Let us see all the cases. Of course, read is not required because read is quite easy. Then we'll see write. Now you want to update a word and which is already available in the cache, simply update it. Okay, then immediately go to the main memory and update it. That's it. That is about cache hit and write. Second thing, what if cache miss occurs? If cache miss occurs for write, that means whatever, wherever you want to write, that word is not available in the cache, correct? So that means what, we don't have data in the cache. Then what to do? One thing what we have to do is, first of all we have to go to the main memory and identify the write block and copy it first. Okay, so this is the block where our word is there. Okay, transfer it somewhere. Then after that in the appropriate, then you get the your desired word, right? And you update it. Now in main memory also you update it. These are the three things you should do, but any order you can do, not a problem, right? This is about write through hit and miss cases, right? When hit occurs, what to do? Miss occurs, what to do? Now write through plus buffer, right? We have a write buffer. When you have a write buffer with write through procedure, then what can we do is, first thing, let us take the case called hit. If it is a hit, then directly go to the cache and data is available and update it. Update the right word which you want to do. Then immediately you processor continues with the next instruction. Okay, that means processor won't take the data and it won't write here. Rather than that, processor will continue with the next instructions, but there will be a write buffer. Write buffer contains the updated data, right? That updated data will be transferred to the main memory independently, parallelly. Understand? That means it will be effective, right? There is efficiency, correct? Now processor is effectively executing next instructions and this buffer is transferring the data. For that you should have extra circuit so that it can automatically do that. Understand? But the only thing is, no one should use that memory at that time. Second thing, sometimes what happens, this buffer will be I can say full, it will become full. Why? Example, let's say you have instruction number 1, that is store instruction. Then what we do, immediately we store here, assume that let's say cache hit occurs, then we write here, then we write the data in buffer also. Second instruction, now you processor went to executing the next instruction. In next instruction also, let's say that is write. Then what happens again, you will come to the cache and you update somewhere and you fill it in the write buffer. Because what is the purpose of write buffer? Write buffer is going to hold the temporary data and which is going to be transferred to the main memory. Since transferring main memory to main memory takes lot of time, correct? Already I told you how many cycles it takes, 100 cycles or 50 cycles. That's why before these 50 cycles, your processor might execute lot of instructions in that 50 cycles of time. Then new store instructions might encounter and it will fill your buffer. Try to understand. If buffer is also very fast, if that buffer also can do transfer from data from this here to here in 1 nanosecond, there is no problem. But that won't happen. If it happens when one cycle, if we can write in main memory, then why we use cache? That's why. Main memory is so slow, right? That's why, so this buffer sometimes becomes what? Full. At that time, what to do? Your processor should wait. Why? If processor don't wait, then what you have to do? Then for that instruction, you have to go to the main memory and you have to write it. It takes lot of time, correct? And maybe this important information might be required to that processor. That's why we have to wait if this buffer is not transferred here. Understand? Two reasons. If there is no space, then where you keep the next data? Understand? That is about write buffer, right? Now we have not completely discussed write buffer, right? Write buffer, finally hit case. In the hit case, what we do? We directly come to the cache and we update the word and we keep the data in the write buffer, so that whenever write buffer gets time, it will write in the memory. Okay. Now second thing, if cache miss occurs, last case, write through and cache miss. Okay, miss here I write. If it is a miss, that means what? Data is not available. This is your data. W. But it's not here. Cache miss. Then what to do? First, transfer all the data to, because we have to transfer all the data, right? Transfer all the data to cache. Okay. Now, update it. Then give the data to write buffer. My dear write buffer, please, whenever you get time, I am giving memory address and data, go to the main memory and write it. And processor will continue with the next instructions. In that way, we can at least reduce some time. Okay. So this is about write through procedure. Now we'll see write back procedure. Okay. So in write back procedure, what are we going to do is we are going to postpone the transfer. That means this is your cache. First we take hit case, okay, and we are talking about write back and write through procedures, especially for writes, right? Read is very easy. Now you want to write some data, but data cache contains the data. This is the word you want to update. Okay. Now cache has it. Then what to do? In write back procedure, simply we update it. That's it. Very quickly. Correct. That is nothing but accessing the cache. We access the cache. We access the write word and we modify it. Then we don't store it in main memory. And we will have that inconsistency with us. Okay, that means there is an inconsistency. That means, example, this data is 30, but same word might be 20 here in main memory. So then suddenly someone access this main memory. Who will access? Already I told you, right? There is a disk sometimes independently access this main memory. So when transfer from main memory to disk occurs, then at that time, so somehow your circuit, your processor should be centralized, so it should understand, and first at that time in write back procedure, forcefully this entire block will be, because we don't know which one is updated, so this entire block will be moved. Then later direct memory access will happen. Direct memory access is, we will be discussing later. At this moment you say transfer from main memory to disk is called direct memory access. Okay, that's enough. Understand? Now let me summarize. Hit case. Whenever there is a hit in the write back scheme, we will update only the write word in the cache, but we don't update in the main memory. But suddenly when some external event occurs and that wants to take the data from main memory, then immediately the corresponding block will be moved. Understand? Now second thing, the second reason I will tell you when we will move. Example, let's say, forget about this case where disk is not accessing any main memory. Okay. Now the other case is, you have updated here, but you have not updated here, right? Inconsistent data. Sometimes what happens, let's say this block is main memory block 50, okay, B50. Now we know one thing, we have cache replacement techniques, right? That means what? Always we can't keep this block in the cache, right? Sometimes we have to replace this block with another block. Suddenly, let's say we want to keep a block called B60 because of our scheme. But B50 if you simply erase, and if you keep B60 here, block 60 here, then what happens? Then the updation will be gone, right? It shows again wrong answer. That's why whenever you have a block B50 which has some modification in write back procedure, it happens that cache contains some data which is not present in, cache have some updated data which is not updated in main memory, right? Then at that time, let's call it as B50. This is your B50 block. Then first we transfer all that B50 data here so that 30 will come here. Then later we replace it. Understand? So that is important property of write back procedure. Understand? Now finally you understood how hit happens. How hit happens? Whenever there is a cache hit, we'll be happy. Directly go to the word and update it. Don't update in the main memory. But whenever that block which you have updated here, if that has to be replaced, sometimes we replace, correct? Cache replacement policies we have studied. Least recently used policy we use, right? Because of that, if your block is a victim, then at that time ask everyone to wait and simply move this block first of all to here, and so that your main memory also will be updated. Then later you erase the data. Understand? So that is about hit. So what if miss occurs? If there is a miss, what happens? We'll see. If there is a cache miss in the write back procedure, this is your block, let's say. That means data is not available in the cache. When data is not available, but you want to update, simple. First transfer that entire block to main memory. Yes. Then after that, simply update here. That's it. Okay. So what we do? If there is a cache miss, then like write through, simply move that block to cache, and when you move this block here, maybe that block is occupied by, that cache block is occupied by another main memory block. Then we update that, we know that again, same story. That means whenever you move this block, example, that block will give numbers. Let's say this block number is B10. This is now currently it is B50. You want to keep B10 here because we are searching for B10. Okay, we want to update B10. Then simply move B10 here first. Before that, update B50 here, wherever. That means, example, this is B50. Okay, store the data of B50 back. Then later write into B10. Is it not complicated? Yes, it takes a lot of time. In write back procedure, if miss occurs, then it will be little bit complicated. Understand? Like write through, of course. So let me revise miss again. This is your main memory. This is a block. Let us call this as block number 1. Otherwise, let's say main memory block 1. There is another block called main memory block 2. Currently, this cache contains main memory block 2, okay, MB2. Now you want to refer a main memory block 1 because you want to update some word in that. Then miss occurs because main memory block 1 is not available, let's say. Then what we do, we replace main memory block 2 with main memory block 1. Sir, why you replace main memory block 2? Why don't you write main memory block 1 in another place? It depends on your cache, I can say cache technique, right? Mapping technique. Are you using direct or associative or set associative? It depends, right? Assume that it is direct mapping technique, and that direct mapping technique says that main memory block number 1 should go here. Then what to do? Simple. Simply move this main memory block 1 here first. Before that, all the main memory block 2, the content, please update here. Okay. Because you might have updated it before, right? In write back, sometimes we don't update in main memory. Recall. So if it is main memory block 2, why we have to move that main memory block 2 is because main memory block 2 might have been updated earlier, but we did not update in the main memory. That is what write back procedure. It happens in write back procedure, correct? So if you have such data, then first update in main memory block 2 so that now main memory block 2 is properly updated. Then write main memory block 1 here. Then after that you do whatever you want. What did you want? You wanted to update some word in main memory, correct? Update it. So if I update some word here now, but main memory block 1 in main memory is not updated, right? Recall write back procedure. In write back we do that later. Understand? So this is a way, so write back procedure works. Even in for write back procedure also, we can use write buffer, but I'm not discussing that things. Okay, you can just think about it. There are a lot of optimizations possible. That's why in GATE exam, nothing is standard. They can't ask, a particular question without, explaining the complete scenario. That's why don't worry. Understand the concepts, that is enough, right? So understand the write back concept and write through concept. But in one line, can I say one thing? In write through, immediately we update. In write back, we postpone the decision rather than updating immediately. Whenever sometimes we have to replace one particular block, then at that time we will do that. And one more question. So when do we know that the data is modified or not? Sometimes it is required. Example, you have a cache block. If it is not at all modified, imagine if it is not at all modified, no word is modified, then happy. Then why to move that? Why to update in the main memory? Not required, right? That's why every cache block will have a bit called modified bit. Remember it, okay? Any word in any block in the cache is modified, we will make it 1. So that some blocks will get modified bit 1, some blocks will have modified bit 0. Now if you want to replace any block, if it is not at all modified, then we don't require to replace, right? I mean, we don't require to move it, correct? Let me show it again with one example. Let's say you have not modified block. This is, let's say, non-modified block. Okay, remember it. Now let's say I'm talking about a particular case called, of course, write back in miss. Okay, whenever cache miss occurs, generally what we do, we will go to the main memory and definitely we have to fetch it, right? Example, let's say we are searching, we are looking for main memory block 1, which is not available, but currently this is main memory block 2, but main memory block 2 in throughout its journey got not updated. That means nobody wrote anything, so that its modified bit or dirty bit is 0. Then in that scenario, what we have to do? Step number 1, directly, because main memory block 2 is not modified, then this content and this content same, then we don't really needed to update this one to here. Then happily go to main memory block 1 in the main memory and ask, my dear main memory block number 1, according to direct mapping technique, let's say, or any mapping technique, what is your position in cache? This one. Oh, then simply because its modified bit is 0, then happily we write MB1. That means we did not move MB2 to here because data is not modified. So we can reduce the time, right? That's why modified bit is used. Understand? If modified bit is 1, that means data is modified, then first we have to move the data to main memory. That block has to be updated. Then later our desired block should be brought, MB1. Then later the right word which you wanted to modify to be modified. That is about dirty bit or modified bit. Okay. Now I talked about only miss case, right? You think about hit case. Okay. Easily we can understand. If cache miss occurs, if cache hit occurs and the procedure is write back, but data is already dirty, then what you do? Think about it. It's same, right? So this is all about write back and write through procedures. Understand?